So today we'll be checking out more customers data set. So we have uh, four different columns: gender, age, annual income, and spending score. So yeah, let's get into it. So today we'll be trying to make k-means clustering classification, and also we'll be using logistic regression to predict a new data based on the classification that has been classified or clustered by using k-means clustering. Okay, there's an error. Okay, I see. I plot. So we have these libraries imported. Let's get into the data set. Let's import the data set using pandas. So there's the data. So we have gender, age, income, and spending score. Yeah, so let's go ahead. So there's the data. So there are no null values, as we can see. Let's check out the distinct values. So we have two gender, 200 customer ID, and so on. So we'll have to drop the customer ID and probably age as well. Though you will have to put it within the brackets. So let's import k-means cluster. So the square sum. So we'll have to find the best fit of the number of estimators or the number of centroids that would make it much more sensible. The number to classify the number of classifications and number of centroids. So let's take like we cannot have one centroid that just doesn't classify anything, uses the data itself. Sorry. So having it should start from 2. So it starts with 2 and maybe till 10. So the range of 2 and 11. So it's called inertia. Okay, so we didn't assign x. Instead, we have given it as df. So let's assign it at x. Or we can assign it there, just below. X is equals to df. Basically, we want the annual income and spending score to be our x. So we have the values of, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 clusters starts with 2. So starts from 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 9 clusters, and we're trying to plot it. And this is called elbow graph. X being the number of estimators or the number of centroids. Elbow point graph. Five seems reasonable and most efficient. After which there's not much difference. So we can go with 5 number of clusters. Let's keep it slightly bigger. Okay, it's not necessary here. So let's try to plot the data, original data, and see how it looks like. So x-axis would be annual income, and y-axis would be spending score. So there's the data. So I think we can already see one, two, three, four, five, six. Oh, okay, we have actually going to take so one, two, three, four, five. Since we have already taken five number of estimators, a five number of groups that we are going to classify. So let's assign it to the model. And estimators is five, and clusters, I'm sorry. And estimators come in random forest, not here. Okay, sorry, this is n cluster, number of clusters. So yeah, we have five different classification clusters, starting from 0, 1, 2, 3, 4. It's five. So we can see along with the index values as well. 0, 1, and 2, and 3, and yeah, I think it should be fine. So we'll have to convert this into a data frame, and we'll have to concatenate with the original data frame. So let's see. Let's try to plot. So x of where y is value is 0, we want its annual income, which will be our x, and we need for the y, we need the same, except we need spending score. So this will become our y for the plot. Colors, so we're supposed to assign different colors so that we are able to understand each cluster. We are able to visualize each cluster group. So let's do the same for others as well. So it means wherever the value is of y is changing, there'll be a different group, right? That's a different classification cluster. A cluster's value starts from 0, 1, 2, 3, 4, but in terms of groups, we can just call it as cluster 1, 2, 3, 4, 5. Maybe change some colors. Probably maybe white, oh, sorry, violet, okay, pink. The violet doesn't look good. Sorry, yeah, the pink, I mean, pink doesn't look good. Even the yellow doesn't look good. It's very, there is no contrast, or the strength of contrast is low, so let's try to change that. Let's probably try violet, Yes, violet, yeah. Yeah, that looks like a pink itself, but it's at least fine. It's not dull. So we can see that, okay, we can see that still not, something doesn't seem fine at that point. So let's try to change the random state or try to see how it works. But not sure. I don't think it would make a difference. But anyway, just try and see. Yeah, I don't think it, yeah, it wouldn't affect because the number of, it is still going to be grouped the same based on the distance between the centroids and the each distance value. So it should ultimately from the same clusters again. So yeah, no change. Yeah, I think it should be fine. See, no, it doesn't change. Okay, let's try to plot the centroids. So it's called, I think, k-means dot cluster center or center cluster. No, cluster center. Yeah, cluster centers. So we have five, which is all we need. All we need the first value, which would be our x. So the indexing would be 0, and for y, we would change that to 1. So that'll be our y values. So 0. Okay, let me show you that. So yeah, you can see the values, right? So x and y. So let's just take the whole example. So we have x and y. So x, y, x, y. So all these are five different centroid, and we need to take the x, y. So we need to take all the x at once and all the y at once. So we need all the values. So we call all the values and give an indexing of 0, which calls all the x, and the same to y. So when you change that to 1, which could call this is 1. 0, this is here x, all the values, and y is 1 with all the values. So now this becomes our x and y for centroid, and now we are able to plot it. So color, yeah, we can change to probably cyan or cyan. Label it has centroids, I believe. All this. So red is group 1, blue, black is cluster 3, green is cluster 4, white is cluster 5. They have all these values. So x of y equals 0, we get these values. So if we do the same thing for 1, so x of y equals 0 is red. So let's assign to x1, and we can see that it's a data frame, so we can add, we can assign the value as 1, which implies the classification as, first cluster or first group. Let's assign the value to 1 here. Yeah, so we got it here. We still have the indexing with us. Let's go with 2. We call it x2, where y equals 1. We can call it classification 2. So we have that assigned. So we can do the same thing for 3, 4, and 5. 5 groups. With 5 different clusters. For 3, it's group cluster 4. Let's assign it 4. The value could be 3, but it's still the cluster 4. The same thing. So last one. Okay, so it's done. Now let's try to, perform a logistic regression. Let's concat this first. So let's merge it. Let's call it class df. So we have it here. So we still have the index with us. Let's save this. So we should get it by now. Wait, let's refresh. Yeah, it's here. Yeah, we still have the indexing with us. Let's check it out. So anyway, we know this data set because we did it. We know the data frame. Okay, let's add it to the original data frame. So, okay, I think we have deleted it. Draw it from the original data frame. Let's remove that. Suppose. Yeah, I think it will work. Let's run it over. Okay. Mm, one four four equals class class statement. Yeah. So wait, let's add it to the main data frame. So we see that's the beauty. It gets added to the original index. Well, we're supposed to class. We have male and female here. So we need to probably do a label encoding. Pre-processing. sklearn is a huge library. So yeah, it's done. Let's talk by yes customer ID. We wouldn't require that for the logistic model. I mean, it's not relevant, the customer ID. It's not a numerical value. I mean, it doesn't hold a value. So let's train test split x test, y train, and y test. Okay, so we haven't done our xy, so let's do that. So x is everything else except the target value, which is classification. So we have to drop that. X is 1. So y is nothing but a target variable or target column classification. Some call it label as well, target label. So y, uh, 4, 2, 3, something doesn't seem okay. Okay, let's just set the random state to be 10. Next frame, for value, let's go with y. Let's fit the logistic model, so sklearn model, linear model, import logistic regression, test, Enter model dot. What is the issue? Okay, sorry. X train, Y train, sorry. My bad. Model score, comma Y test. 93% accuracy is great. Small dot predict. So let's try to predict. Yeah. 0, 0, 16, 77. Okay, well, let's just put a comma instead. Sorry, break and see it's type 4. Okay, 4. Yeah, it's good. Try to change some values and see. Oh, we don't need that 4. Let's see something random. 30. And let's set the spending score as 5. Second 4. Okay. Set of female. This is the annual income. So that's income, and that's score. So low income, low score. Oh, it's still 4. Something seems okay. 3. Okay. Okay. Well, it's fine. Use classification. So high income, high expenditure. High income, low expenditure, or low spending score. High income. Yeah. So high income, my spending score is 1. Cluster 1. Or cluster 2. Sorry. Value is 1, but cluster 2. So blue is cluster 2. High income and high spending score. 2 is blue. Yeah. High income, high spending score. 2. 1 is red. So average income, average spending score. You can say high income, high spending score. Blue. Group 2. High income but low spending score is black. Group 3. Cluster 3. 4 is green. So low income, high spending score. That's 3. No, wait, there's 4. If something seems messed up. Well, okay. I've given it as 5. It's supposed to be 5, I believe. Oh, yeah. Okay, let me check that. 1, 2. Wait a minute. Okay, relatively high income, high spending score. like high income, low spending score. High income, low spending. Yeah, makes sense. Green is cluster 4. So that's low income, high spending. So yeah, low income, high spending. Yeah, makes sense. 4. So the fifth one is okay, low income and low spending score. Okay, there's some sort of a relation you can see. Okay, but this is supposed to be 5, right? Mm, oh yeah, it's supposed to be 5. Okay, we made a mistake there. It has to be 5. Yeah, I think this is the one. So yeah, I think now we should be fine. Okay, it doesn't affect the score, is it? Now let's try to see. So okay, that's age, high age, mid income. Okay, let's keep it. Yeah, 40s, high income, low spending. So that should be. Yeah, what exactly? Okay, let's run it all over again. Some issue. Okay, it's 90% accuracy. Okay, so mid age, high income, low expenditure. So that should be high income, low expenditure, black. So that's 3, cluster group 3. Let's see what we got. Yes, we got 3. It's correct. So we got a cluster 3, which is high income, low expenditure, low spending score. Let's edit high expenditure, high income. So that should be a blue is cluster 2. I hope it's a cluster 2. Let's see. Yes, we got it too. So that's a group 2 kind of people who have high income as well as have high expenditure. So, so that's it. So I hope this has been helpful and yeah.